All right, welcome back. We are COMP301, that's Linux operating systems in the summer 2020 semester, and it's week 7, part 2 of our broadcast. It's Intro to Python continued, and we're sitting here on a Thursday afternoon, and the sun is hot in Toronto, and it's pretty crazy. So we're going to start off with a couple things. A bit of a review of what we did yesterday or on Monday, and just go through the schedule one more time. So schedule says that we're supposed to, again, there's supposed to be an assignment 3 that is going to be due week 9, and I wanted to give it to you today so you had a couple of weeks to do it. I'm probably going to move this out a little bit. And only because it's not because I don't want to, I don't want to give you an assignment. I'm fine with it. I just don't think there's enough. You have enough, to get stuff as an example to get going with some things. So that's why I'm gonna wait till next week. Probably Monday, I think might be best, and it'll give you guys a chance to finish off some of the other stuff that I've given you in other courses as well, right? So that's what's happening now. I'm not going to do the assignment today as I planned. So that's one thing. We talked about last week. Last day, we talked about Python a little bit, and I'm going to talk more about Python today. Let's also talk about, who made Python. So this guy Luigi, right? No, this guy Guido. Guido is the one who did it. He made the Python programming language. It was he really created it to solve problems. It was a high-level language that he wanted to make. So remember, when we say high-level language, it doesn't mean like it's very powerful or something like that. It means there's enough levels, a lot more levels of abstraction compared to going down to the machine level. All right, that's what high-level means. So the higher level your language is, it's farther away from the machine code. So far away from zeros and ones, as an example. The lower level of languages, the closer it is to the machine, which means something like assembly, would probably be the closest that you want to get, at least in this modern age. And even that is too close, in my opinion, for it to be practical. If you're going to write full-blown applications in assembly, you may want to take one step out from assembly and go to C or C++, and I think that would be the next level higher that I would want to write in when it comes to doing stuff. So that's just me. But Python is quite high level, and I would say it's even higher level, way higher level than C# and Java, because there's a lot more abstraction. There's a lot of things that are done for you. We talked about some basic things last day. One thing that we've talked about also is that Python is it does automatic garbage collection. A lot of memory management happens on the fly. You can see here from these slides. The last time this was recorded, 3.12 is the Python shell. We're into 3.8 right now. And we talked about how to run statements on the command line. We do some prints. One thing to note is the print statements have an end to them. N is equal to this. Actually, what that does is this is the general form of a print statement. Well, I'm going to go more into that with you today. So I've opened up the ability for you guys to change your names just in case you need to do that. So let's go into my little Ubuntu VM. So again, we're doing this for Linux. I don't know if you noticed, but I've moved my VM into a VMware workstation environment. I'm out of VirtualBox going forward. And I'm doing this because, again, it's just more learnings for you. I'm trying to push you guys to do more stuff and to use other things. And so I've reconfigured Ubuntu in a VMware kind of environment. Remember that you have access to download and install VMware through the Centennial College software portal, right? So you can grab VMware, and it'll give you a year kind of free. This is version 15.5, I believe. Let me see what that is. Workstation, yeah, 15.56. So that's the version I'm using, and it gives you kind of a free chance to use VMware. I think it's a great platform. I like it more than VirtualBox, but it's not free like VirtualBox is. VirtualBox is great for what it gives you, but VMware does more stuff for you, I think. This is my opinion. So, so last day, what we did was we ran this little program, first.py, and here's first.py. All I did here was I just downloaded, or I cloned my lesson from GitHub, right? That's what this is. And again, you can check that, because if I go git status, it says on branch master, my branch is up to date with origin master, nothing to commit, and my working tree is clean. Okay, so that's what I had there. And we did a couple of tests. We talked about a bunch of stuff. One thing I ended off with last day was, triple apostrophes or triple quotes are kind of multi-line comments. That's how you do multi-line comments. Single-line comments, again, we do it with a hashtag. That's the difference between Python and other languages. I'm just going to make this a little bigger for you guys so you guys can see this. We talked about things like, well, I want to print a day of the week. These are lists. If I hover over lists of type string, you can see the types. So it actually does detect types. There are types. It's just that they're implicit as opposed to explicit. So similar to JavaScript or another language like that, we don't define the data type. We let the data type be defined by the value that we assign the data, that we assign to the variable. I don't need to use let or const or anything like that when I do this. We also talked about how to loop, and there's a couple of loops we used, loop examples. This is one for day in weekdays. So here's weekdays, and then here are months as an example, and you can loop through each weekday, and then you can print out the the 0th weekday, it's 0 based counting. Yay, awesome. Let's move on and do a new thing. So I'm going to go back into my project, and I'm going to add in a new file. I'm going to call this new file second. Why not? We called the first file first, we'll call the second file second. And in second, I want to talk about a couple of additional things. So remember that we talked about how to concatenate data a little bit. I want to show some data. I can interpolate. So if I have, let's suppose A is equal to 10, and B is equal to 20, and I want to print out, A and B. Remember, what we need to do is we can interpolate A, and then let's say plus B, and then we can do some kind of evaluation at the end, right? We can do that. So we can say that C is equal to A plus B. Very basic stuff that I'm just going through so you understand the workings of the language. And then equals to, and then curly brackets C. So this, if we do everything right, should work. I'm just going to go to my command line here and just type in Python and second. And if everything goes well, it's going to say exactly what I told it to say, right? A, B, C. If I put an F in front of it, so if I put an F in front of the string, as an example, and I try and do it again, now I get 10 plus 20 is equal to 30, right? So just to notice that. So if I don't put the F is a format, that does it. If I want to print them separately, so for example, I want to print A plus B is equal to C, and I want to do a \n here. So if I said \n, which we're used to as a control character in other languages, so \n, and I kind of say yes, save, and I do it again, you can see that 10 plus 20, now \n comes into play and it goes down to the next line, so it adds a line. As an example, that's one of the ways to do that, right? And same thing with other control characters. For example, \t, right, would be something like a tab character. So let's try that out. You can see that that tabs the data out. So \t also a control character. Okay, so all that's possible with F. But if I wanted to see the characters, I can use R. Right, R is raw, right, a raw string. And whatever I type in here, \n as an example, let's see what happens when I do this. So I go up and \n. I actually see the \n now, right, where before I wasn't. So R does that. If I take R away and I try it again, so I kind of go in there and I go through it, it does the \n character. It executes this, but it doesn't actually interpolate. It just, you know, leaves everything in brackets. So that's the difference between F, R, and nothing. Okay, so F is the one we want, and that'll execute and interpolate. Okay. But what about if I don't want to go to the next line? So let's suppose I have another line that I have, you know, something like space is a great result. Right, let's just say. But if I normally do this, and if I type in Python, you can see that 10 plus 20 is equal to 30, and is a great result happens on the next line. Right, see that? Is a great result happens on the next line. If I want it to go on the same line, then I gotta type in, because remember, from a general form perspective, just what we just saw, general form, we have this comma and then and equals. Okay, so if I go and equals to nothing, so if I say something like end is equal to nothing, all right, so no end, and if I try it again, then you can see that 10 plus 20 is equal to 30 is a great result, is printed on the same line. The \n character that normally comes around with the print statement, as an example, is not included. What about if I added something else? If I said something like \n, like what if I added that in? Is that possible? Can I do that? Being explicit with Python as opposed to none. And yes, I can. I can do that, right? So again, I'm just going through this so you understand some of the statements. Okay. Other things that we want to do. Sometimes what we want to do is we want to multiply, and there's a couple of arithmetic operations we can do out of the box. So for example, if I want to do, I want to calculate the distance between 2 points, as an example, and I like doing this kind of example, which is good. Let's suppose I just want to calculate the distance between 2 numbers, right? And or just do some kind of arithmetic. Can I not use something like square root? Is that possible? You know, is that a function that I can use? What about if I want to, you know, do some kind of exponentation? You know, something like that. I want to, something to the exponent of something else. So let's say, for example, I want to say e is equal, an exponent, as an example, is equal to, you know, a, and then to the exponent 2, right? So that's like 10 to the exponent 2. What would be e then? Let's print that out. Print e. How would that work? And that's equal to 100. That's how you do exponent. So star star. If we can do exponent, so power, then I can do square root, right? So if I wanted to say, you know, if let's suppose that I want to go to square root, I can just go 0.5, right? So half, if I go to the half, that is equal to kind of a square root. Let's see if that works. And you can see that indeed 3.16227 would be the resulting number because it took it to the half, right? So a to the half, and so on. So that's kind of how you can do a lot of really interesting and quick calculations with with Python, and there's a lot of other stuff. Division is the same that we've seen before. We can also use something called floor division, right? Which is basically it's numerator divided by denominator, and then it takes the highest integer that's not the greater the result, and what it does is it truncates and discards the fractional piece. All right, so let's suppose I wanted to try that. So I want to say something like floor division. We'll call it floor, and I want to say something like 5 divided. It's double divide by 2 as an example, and I want to print floor, whatever that is. Let's take a look and see what that does. And you can see that did I save it? Haha, I did not. Floor is 2. So 5 divided by 2 is 2.5. But because I'm doing a floor, right, it's basically rounding down. Right, that's what it's doing. So it's pretty simple in terms of what it can do. And also we can use the remainder operator in a very similar way. So I can say something like remainder, right, is equal to 5% 2, and then let's print that out. Print remainder, right? So what would that be? So we're going to see that that is a remainder of 1, right? So 5 divided by 2, well, that is equal to 2, right? Because it's, example, I take 4 divided by 2 is equal to 2. 5 divided by 2 is also equal to 2, but there's also an extra remainder of 1, and that's what we're getting here, the remainder, or the modulus, right? So that's what we're getting there. And I'm going through this with you because a lot of times what we want to do is we want to make simple calculations through Python. A lot of times Python's used for data analysis and so on, and I think it's important for us to understand how to do that. The other thing that Python can do, and if I wanted to do string concatenation, kind of like interpolation, but I want to concatenate the values instead of interpolating the value. Interpolation means I inject the values, right? And as long as I use the F for format in a string, I can inject values. But I can also concatenate. So if I said something like print, I want to say something like A is equal to, and then I want to print out the value of A. I can't do this. Remember we tried this? And when we tried doing this, it's going to give us a traceback. That's what it's called. So a traceback. So if I was to do it, it'll say traceback, I'm sorry, but you know what? You can't output an integer, right? But what you can do is convert it. So if you use the str is a built-in function that actually converts it to a string. And if you were to do this, then if you go back to the terminal, again, you'd see A is equal to 10. So you can do it that way too. You can concatenate like normal, but you need to convert it to a string first. So far, so good. Any questions so far before we start to ramp today? Because I'm going to ramp. I'm going to give you more and more and more just to get you guys up to speed with using Python, similar to what you've done with C#. I wanted to get you up to there, right? So because now you're learning C# and you're learning the basics of things, right? And I think this is good, right? I think this is a good thing that you're you're doing that, right? So all right, so how this is good, but I want to get input. How do I do input? We're going to cover input again later. But let's suppose I have some kind of a person's name. I want to get a name. I can say the name is equal to input. And there's a couple things I can do. If I just put input like this, right, and I run it, and then I want to print out the name afterwards, so print name. And we can say that you typed and whatever. We can say that you typed and then plus, let's see if we can do this, name, Remember that name, if I hover over name, it tells you it's a string, so this is okay now. We don't have to convert it if we know it's already a string output, right? And if I was to run it, let's say, so again, if I was to run this thing, then we'd say, okay, so it's asking me for an input. It's waiting for me to input. If I put Tom, you type Tom. So I can get input that way. But wouldn't it be nice if we can just do it all in one, like enter your name? We could do this. We could say something like print, enter your name, and then I could put in end is equal to this, so I don't have any end. And then I can give myself, making sure I have a space, like this, enter your namespace, and then enter the name. And then let's try that out. If I was to run this sequence, then it's going to say enter your name, so Tom, you type Tom, right? That's nice. But then you can also do it, remember Python, right? Python. You can also do it like this. If I take my string here, what about if I took it and put it in here? Is that allowed? Can I do this? I'm going to just comment this part out. So you can see that name input, enter your name, as an example, is kind of all in one. And if I was to clear it and try it out again, then it's going to say enter your name, right? So that also works. So just to let you know. And why would they do this kind of thing? Well, they did it because remember why Python was written. Python was written for simplicity. Python was written to help, you know, not to hurt, right? So it's trying to make it so as simple as possible for you guys to get going with, you know, making calculations like these, you know, kind of thing. So we can get data from the terminal this way. Enter your name. Okay, so pretty straightforward stuff. So after we get data from the terminal, we also want to be able to, we can do something with it. Also, what I want you to know is that the input function always returns a string, and we need to convert, right, from a string into something else, for example, an integer, if we're going to get data from the terminal. So let's say, for example, you type this, and then let's say if I want to, you know, I want to get some data like x and y coordinates. I can say that x is equal to, we'll call it x string for now. X string, we'll do it in two. X string is equal to input, you know, enter the x value, right? And then that's the x value, right? And what I want to say is x is equal to, if I want to make it int, I can just convert it like this, int x string, right? X string, which converts it, and then I can say y string. By the way, you can make it right. You can write this all in one line, right? Enter the y value. Okay, and then so we can say y is equal to int y string. Okay, so we can do that, and then I can print them out. I can say print, as an example, f x comma y, right? Let's just do this the right way. So I want to kind of print out these brackets, almost like a formatted way of doing things, right? There we go. I want to print that out. Let's see how that looks. So again, control backtick, and we'll go into Python and see how that looks. So it says enter your name. So Tom, you type Tom, enter the x value. We're going to say 5.3. See what happens to the value. And it says, immediately it says 5.3, trace back the second pi, .py line 25 of module xint, value error, invalid literal for int with base 10, 5.3. So try to enter something else other than integer. I entered another value, right? So I think this is important to understand. So what if I wanted to enter, instead of entering an int, what other types could I enter? Could I, as an example, try and enter a float? Is that a thing? Well, let's try it out. If I go float, then that works, right? So I can make it a float that way. What if I wanted to make it some kind of decimal? Is that a thing? No. So not like that. What about if it was, instead of a float, if it was a double? Is that okay? No, right? And you can tell that it's not because it gives you an error right away. But float seems to be okay. So let's say I wanted to make x and y floats. So I can go like this instead of, that would take care of my issue, because x and y maybe should be floats as an example. And let's just run that thing again. Tom, and then 5.3. Now it's working, right? 3.7, and then you typed 5.3 and 3.7. That's the coordinate for this, right? So pretty straightforward stuff for that too. All right, so that is how you do that. Float, the float function. We talked about decision making last day. If and else, elif. Those three things, we can do those things. And then we briefly, very briefly, talked about functions, right? And the way functions work is you use the def keyword. So again, here going back to review from last day, we use the def keyword and then the function name. So example says hello, or say hello, right? So these are all really good things. And I think, and this is how we start off. We start off with this kind of stuff, right? All right, what about, let's ramp it up. Remember, we talked about this is going to ramp for you guys, right? So, and what I mean by that is I want you guys to be up to speed so we can do anything we want to in Python and not have a problem, right? So let's close these ones off. We'll keep this open up. I'm going to put this up on GitHub. So again, here on, I'm using the built-in GitHub. I'm going to say, well, second is a new file. I'm going to add it to the, kind of the staging area here, and then I'm going to say added second.py, and then I'm going to press the check mark, which is like, it's like saying git commit -m and then added, and then I'm going to push it. Now remember what I had all those really weird problems, right? Because it's going to try and push. And now it's going to try and log me in. It says, would you like code to periodically run the git fetch? And the answer is no. And what this has done actually in the background is it's done it for me. And I've set it up so that I can push to the repository whenever I want. And I've done that through GitLens, which is just another extension. So I don't have to be asked every single time, do you want to log in? From a credentials perspective, who wants that? So if I go to github.com, I see I have an update. I have an update that's weird. github.com/Centennial College, right? And if I look there, you can see that I've just updated the project, and now it has two things, first and second. So you can always go to second and take a look at kind of the little test that we've done. Anything that we talk about is there for you to look at, okay? So you can practice in along with me, okay? Cool. All right, so we did that, but we need something new. So I'm going to go back to this, and let's make our first class as an example. So I'm going to make a new file. I'm going to call this the person class. You guys have kind of done this before. So how do classes work? Classes work with the class keyword, right? And I can use the class person like this. At the end of the class name, again, if I just did this, right, as an example, so the class person, that wouldn't be good. I want to include object as the superclass. So object is the superclass of person. And then what you want to do is you want to use a constructor. So the first thing is, here's the constructor function. This is how it works. The constructor looks like this, def. It's like a function, except you have a special way of starting the constructor in Python. It's __ init. That is a reserved kind of word. I'm not going to use that arrow function for now. And this is the constructor. Basically, it's saying, right now I'm just taking, it's the empty constructor. And in my in here as an example right now, I'm just going to say something like, person created. So print person instantiated. That's all it's going to do. So we're going real slow here, okay? And then if I exit out of here and down in here, and I want to make a new object of type person, it'd be like this: person is equal to person, right? Pretty straightforward. And then if I want to print, person, I could do that. Let's see what that looks like. Because remember, things are weird, and we'll see what it does. Okay, so again, I'm going to go clear the screen, and I'm going to go Python, and now it's going to be person.py, and it says person instantiated. So I actually did my bad spelling, instantiated, and it said main person object at, and it gives us a reference. This is interesting. This is the first time you've ever seen this, but it's basically able to print out objects just like this: person object at, and it gives you the memory address, which is interesting. Yes, that's what that is. So that's how you would instantiate person. If I want to take more kind of instances into person, for example, name and age, which is a classic example again, I could use the keyword self. Self in Python is like this in other languages, okay? So I could say something like self.name, as an example, is equal to name, self.age is equal to age. Okay, so I could do those things. And if I wanted to add in a method, right, as an example, I could, down in here, make another. I need to notice the indentation is important. Remember we talked about this? Indentation means that anything that's indented to this level, and nicely Visual Studio Code is telling me that these are all indented nicely, that these two things are in the code block for the constructor function. Okay, that's what they are. So if I say another function, def, and I have a thing that says hello, right? As an example, I need the colon at the end. Then I can just print kind of what we did before. We can say something like, and we'll do the F in there. Oops. F, and we'll say that in curlies, self.name says hello, right? Self.name says hello. Notice the self. The self is not defined in Pylance. Why? Because it wouldn't be defined unless I pass in self here. So I need to kind of pass it in as a default. Notice I'm passing it in every single time. I'm almost passing in a context for both the constructor and for each of the functions that are inside of the person class. Because these are indented inside the person class, if I don't pass the keyword self, that is a different kind of function that does not have access to the context, right? Which is interesting, but useless. Notice now that my person variable doesn't like the fact that I haven't asked for this. So what I have to do now is I have to at least enter name and age. Let's add that in. So I'll say Tom, and then I want to add in an age. Let's say 30, right? Which is not true, but it captures what I want to do. And then if I want to use person dot, I can do the dot accessor. Notice I have age and name here, and I also have says hello, which I want to call, right? So the calling parentheses. So if I was to do this and run python.person, then you see Tom says hello, person's instantiated. Questions around classes. We just did a class in Python, right? I'm doing classes in Python with you because you're doing classes in C#, and so it shouldn't matter. It's just syntax, guys. It's just syntax. Do not worry about, as an example, how it functions. You should just be able to do classes because we're doing them in C#. And now, if you're with me on JavaScript, you're doing it in JavaScript too, right? So so you're doing it everywhere, and I think this is a really good way of assimilating the learning that you're doing from one language to another. Okay. Questions around this before I move on? Are we good? Can I move on? Check marks for good, X's for bad. I got a couple of check marks. Oh, we got some more check marks. That's good. Awesome. Thank you for that. Okay, I'll just clear all that up. Thank you. All right, so this is good. So person class, yeah? All right. Well, how do I use the person class in another file? Okay, let's make another file here. First of all, let's put this up on GitHub. Again, I'm going to do it the command line function way now. I'm going to say, let's see if I can do this. Git add dot, git commit -m. We'll say added the person class. Yes, and then git push origin master. And if I did everything correctly, it's just going to push it up, right? Nice, nice. All right, so that's done. This is over, and I'm good to go. And you can see now that you have this example, but I don't want to have this here. This is inside of my file person, and wouldn't it be nice if I had a file as an example that was separate? Let's make that file main, the main file, right? So I'm going to make a new one. I'm going to call it main.py. There's main.py. And under main.py, what I want to do is I want to include the person class. So it's like I want to do this. I want to say import, and I want to import person, right, as an example, from person. And you're going to go like, wait, what the heck is that? What are you talking about? Where are you importing from, and how come it's giving me this issue, right? So it says expected import from Pyland. It says peak problem is no quick fixes available. So if I just go import person like this, just this alone, right? And if I start typing, and if I say, okay, well, I can't type person because person itself is a thing. So let's say Tom is equal to a person, and well, that is an issue, right? It doesn't understand what a person is, right? Automatically it says person is not defined Pylance, right? So how do I do it? How about if I say it's a new person, and if I go person.person, well, then that makes sense somehow, right? And let me explain this for you guys. So I'll say this is Tom, age 30, as an example, satisfies requirements, and then I can say something like Tom dot says hello, and if I run main now, so let's say for example I run main, I want to say that so we're going to say Python main.py, and you can see and indeed, Tom says hello is good, and everything else, and it's created this little file PyCache, which is something new. So now I'm accessing another file from this file, okay, and I'm using import person. Import is the keyword that we want to use to import our custom whatever, but it's really weird that we have to do this. And wouldn't there be a nice way of doing this, importing a class without doing this? Because I think that would be nice to do, right? I want to import person, and then I want to do something else, right? So actually I have an example of that on my desktop that I was working on earlier today, just to get ready for you guys. So I have person.py. We're going to talk about this, and I want to just edit it so you can see what it looks like. So here's class person, and I did the exact same thing, right? I used self.name plus, which is actually wrong, but let's just take a look at this actually, right? So you can see this is the same structure that I used before, right? This is on the C on Windows side. And what about main? How does that work? So if I edit this, again, you can see that I can say from person import person. This is new. So this is kind of a way of importing, which is the same way as doing it before. So I can say I want to import person, right? But instead of doing it this way, if I said from person, so I'm looking at the person file, it's kind of sensitive. Python is super sensitive about naming. Python something.py, it looks and sees if there's something that's called person, lowercase p, and it found it. So from person, import person. So what this does now, it takes away the need for us to do this. But now it looks beautiful. Okay. And again, if I go here, clear, and I go Python main.py, and then we're good to go, right? Yay, we've got classes. Are you with me? Right? Check marks for you're with me and X's for no. I'm checking with you guys because this is where, you know, we can get all kinds of hairy, right, kind of thing happening, right? Where people are like, wait, I don't know, where did he come up with that? And we're in classes already, and it's week 1. Don't we have to wait for a few weeks to start classes in Python? And the answer is hell no. You guys know about classes, right? You guys know what classes are. And so why would we have to do something silly like wait a week? Or 4 or 2 weeks or 3 weeks or never, like we have here in the program, right? Look. Here, let me show you. Is there anywhere that says here that you're supposed to learn classes in Python? Please tell me. No. That's the answer. There's no place here that they talk about classes in Python. But we're doing an intro, and my intro includes everything, right? Which is where we are right now. Intro to Python, right? And I'm actually showing you stuff that you probably should know if you're a programmer. I mean, you know, like for us to go back and reteach you what a variable is and what a class is, to me is quite silly, right? So that's why I'm doing it this way. But the keys are, okay, so key parts of a class. 1, the keyword class. You need to use that. Remember the colon. The colon is like a semicolon, is like a curly brace for us in some ways, right? It's like the opening curly brace. And then the name of the class, person, right? You must pass in the superclass or the base class. In this case, the base class is the object class, which is the base class of all classes. And that's the same in C# and in Java. It's called object. It might be spelled differently, but it's called object in C# and Java as well, right? So this is good. So this is like object is the superclass of all classes, is the class that kind of each class derives from. And you guys are going to be learning about inheritance next week. Okay, so for guys, you guys in if you're taking C# with somebody else, you'll be learning about inheritance next week. But let's do some inheritance this week. So I want to do inheritance. We kind of maybe talked about some of this before, but I want to kind of use person as the base class for another kind of class called student. So let's make another class called student, right? Let's see how this works, and I'll just do it here. So we'll call this class student. Here's student.py, and we'll make it just like before. We'll say something like, okay, class student, right? And inherits from person. And then we're going to have an issue, because in this file, does student know about person? No, it does not. We need to do an import. So we're going to say from person, right, import person, just like we've done before, right? So what this does is it imports the person class from the person.py file, and now it's accessible to this class, student.py, all right? Just like the person class, we're going to call the student constructor. So we're going to say def, and then we're going to use double underscore, and then notice there's a bunch of defaults, right? So I'm going to go init, and it's going to say self. And inside here, I'm also going to take a couple of things. I want to have my name, my age, and maybe a student ID. Student ID. This is, again, a classic example that I've kind of brought up in many other times. All right, so there we are here. And what I want now is I want my self.name to equal to name. But you know what? This self.name stuff, that's being done by my superclass my person class needs for me to satisfy my requirements. And again, I'm going to go back to show you what that looks like inside of my PyTest file that I had. So PyTest also had a student. So there's student. I'm just going to edit that so you can see what that looks like. And it's the same. So here's person, but then we use this keyword super, which is really interesting. Once we have the keyword super in place, everything else is the same. Let me actually go back and do that. Show you one more time, and then I'll show you how it works. Okay, so super and then init, right? Super init, which is the super constructor for those people who know what that is. So again, I want to satisfy the requirements of my person class. It needs to be when I call person as the base class, as opposed to object, person needs to have its own constructor, which is this one right here. It needs to be taken care of. This is just a method. By the way, do we ever say public or private? No. These are all public. Okay. And so here it's the same thing. So again, super, right? And we're going to say that we're going to call the super constructor, right? So super init. The super init needs a name and an age. We're just going to pass in name and age here, right? Which satisfy the requirements of the super constructor. So this calls the base class constructor. So, and again, if you don't know what this is, you're going to learn about it next week. But I wanted to talk about this idea of calling the base class anything. Anything I want to call from the base class, I can use the super to do it, right, if I really want to. And then what I want to do here is my own constructs, which is student ID is going to be the new thing. So I can say something like student ID with a capital S, let's say, is equal to student ID. Right? This is making that self.studentID is what I want to use, because self is this. When I do self.anything, this becomes an instance variable immediately, just like it did here in person. There was no name and age. I had to assign it. As soon as I assign it, just like in JavaScript, I created it. As I assign it, I create it. That's how things work, as an example. Oh boy, don't crap on me now. And so here's my student. So now I'm doing the same thing. I'm saying that self.studentID is equal to studentID. It comes from the constructor function, and I get it. And the student is different than the person, more specialized, like we've talked about in JavaScript. And I'll talk about this again. And we can say that when we define a new method, we can call this method studies. And the studies method is going to print out something that says, no, I'm not going to do that. No, not right now, thanks. You know, the name, right? So I can say F, and then I can inject self.name. As an example, self.name is still available. I can access it. And then is studying. So here is a simulation. I'm able to use the name property of the person class, which is the base class of the student class, and I can say that the student is studying, right? Whatever that student is, right? We can also something else like student has a the student ID is. And then we can say something like that. Their student ID is, and then we can interpolate again self.student ID. Okay, so that's how that works. So that's kind of both. I'm using my student ID and the name. Age I'm ignoring, but I'm taking it in right now. And so there we have it. There we have a student class. I'll talk about this in a sec, these constructs we're making. So here's person, right? Here's student. And then we're going to go to main, and instead of making Tom a person, we're just going to say from student import student, right? We don't need the person class anymore. Tom is the student now, and he has a student ID of A12345. Okay? And not only does Tom say hello, that's important, but Tom also studies. Okay, so Tom does both things. So he's both a student and a person. And if I do that and I go my Python main, Tom says hello, Tom is studying. Their student ID is A12345. Okay? So it's kind of a very simple way of doing classes. Okay, let's put this up on GitHub. I'm going to say git add dot git commit -m. I'll say added the student class, right? Git push origin master. Oop, that's going to fail. Git push origin master, and it's going to push up to GitHub. All right, questions around basic classes. I dropped my HMD. Okay, basic classes. Any questions around this? No, I'm seeing no questions. Everything's so far so good. Again, guys, I'm going over this stuff because I want you to be comfortable with the idea that this is, how we're going to be doing stuff. I'm going to make classes. I'm going to make objects, just like we do in C#. I'm not going to hold back. I'm not going to say, wait, it's Python. Oh, I've got to treat the students like kids, and I got to take them back to first semester again. Nope, not doing that, right? I want you guys to be advanced, right? So the things I'm trying to show you this semester are trying to push you forward, right? Which means your assignments are going to be assuming some things, that you know how to do classes and objects, right? And it's recorded, so you can always go back and look at these examples, and also there's a ton of examples online to do Python, and you shouldn't have a problem with any of that stuff. Okay, so main is the main class that we're using right now, but there is no class, if you notice, in main, right? There is no class in main. I'm just calling it main, right? I could make a class main, and I will later on, but not today. Okay, that's something of a new thing in the future. We're going to get there, right? Class main, and what that means, what that entails, right? From a Python perspective, how to compile programs in Python and so on. We're going to get there. But for now, what I want you to think about is we're compiling each program. Once we hit, as an example, main, because main depends on student, and because student depends on person, both the student and the person class get automatically interpreted, right? It goes to the Python interpreter automatically, and this PyCache directory that gets created, it keeps track of that kind of stuff. It creates these little objects, these little temporary objects, right? The PYC files, and the PYC files are little binaries. All right, that's what they are, little libraries that hold on to the definitions for students and so on. Okay. Let's do another example. Let's do one more class, okay? So just off the top of our heads, and let's do some other stuff with it, okay? So I want to make a vector class, okay? And I've kind of done this with the C# folks, so I'll do it with you, right? So again, I'm going to go here and not there. I want to go here and make a new class. We're going to call it vector2d.py, right? Vector2d.py. And vector2d.py, it's going to have a class called vector2d, right? There's my vector2d. It's going to inherit from the object superclass, right? That's going to be the base class, and I want to make the constructor function happen here. Here's my constructor. It's going to be def __ init, right? And what I want with this is I want to take in two variables, an x, which I'm going to give a value of 0, and a y, which I'm going to give a value of 0. These values are default values that you can give. And then I'm going to say something like self.x, right, is equal to x, and self.y is equal to y. So that is x and y coordinates for your vector2d object. Yep. So pretty straightforward stuff. And it has a default value of 0 and 0, just in case when I construct something, a vector 2D, I can make it with whatever I want. We could also add in some functionality for Python. For example, what about if I want to do some, I want to add two vectors together. So you know, in terms of operator overloading, that's one thing that for me, you know, when it comes to operator overloading in C#, right, as an example, you know, it's pretty straightforward. Use the operator keyword, and then you can overload, as an example, two things together, right? So, you know, two objects as an example, right? So I want to add two vectors together, and the way to do this, of course, is to create a special function. So def, right? Here's def, and then if I go underscore underscore, and if I scroll down, you know, there's quite a few things I can do. Let's say I want to make an add function happen. This is what I really want to do. I want to add you know, two things together. I want to take two functions, let's say something from the left hand side, you know, as an example, and then another one from the right hand side. I want to add these two things together, right? And that's what's going to, it's going to return, you know, some kind of special function when I add two things together, right? So what I could do, right, is when I get an object that I want to add, I could do left hand side and right hand side, but let's just take, this is not a static function. This is just a, you know, thing. So I want to add something. I want to add the right hand side to this thing. So then what I could do is say something like, I want to return. There's a return statement that you can use. You know, self, right? As an example, I want to take the x and y functions, right, and I want to add them to the right hand side. All right. Now this is, how do I do this? How do I make it so that I can do it? If I only had one function, let's say for example, if I said self.x, right, and I want to add in, you know, right hand side, no problem, right? That's totally good, right? But if I said right hand side dot x, right, it makes assumptions. It makes assumptions because I don't know, there is no type. It doesn't, like, I don't really know what right hand side is. It's not like a right hand side can be defined as a type, you know, by default, right? That's more challenging to do, you know, than you know, if it's, I have to check to see if the other type is a vector, right? Now we're not making that a vector, so I'm just making it like this. So if I want to add two x's together, I could do that, self.x plus whatever that is, .x, right? So let's break it down. So I'll say something like, you know, I'll say the x's is equal to self.x plus right hand side dot x, whatever the right hand side is, and the y's is equal to self.x, self.y plus right hand side dot y. Okay, so there's x's and y's. And then what I can say is that self.x is equal to the x's, and self.y is equal to the y's, right? The y's added up together. And then I can just return, well, I can return nothing if I want, right? I don't have to return anything at all, right? I can, if it's just a function that I'm just adding to myself, I can just make it so that it returns nothing, right? Yay! So let's test this and see if this thing, this, you know, monster works for me, okay? Let's see if I'm right. So I'm going to go back. First of all, let's add it in. So I'll say something like git add dot git commit minus m. I'll say added vector 2D class. There it is. Git push origin master, which will push it up to GitHub for you, right? So there's a new thing with some kind of operator overload. I'm trying to overload the binary plus. I'm going to add like that plus sign so I can do this plus something else. Let's see if this thing actually works, right? As an example. I think these are important, kind of things that we want to do. So I'm just trying to kind of figure out how this would work in this new environment. Okay. So how does this go? So I want to do this, and I want to go to main. Does it work at all? Now I have to import this as well, another import. So I'll say from vector2d, right? Import vector2d. So I'm importing the vector2d class from the vector2d file. That's what this is. And files are like modules, if you will. Once I separate them into files like this, they become namespaces by themselves. Their own name, if you will, or their own module. So then let's test it out. I can say something like point, or we'll call it position, right, is equal to a new vector2d object, which I can pass in x and y if I want. So let's say something like 20, 0.0 and 30.1, right? And then what I want to do is I want to take another one. So we'll say that will be, let's say, position 1, and then I want to add position 2. And let's say this new position is 10 and 10. I want to add that in. Okay, so I want to add one thing to the other thing, right? So then we should have out 30 and 40.1. Okay, so that's what the final position should be, right? Or position. That's what position 2 should be at the end. So I can say something like position 1 is equal to position 1 plus position 2, right? And let's see if that works. So I take position 1, which is a vector 2, position 2, which is a vector 2, and I want to store it back into position 1. Let's make this, just to make it simple, make this position 3, so we kind of keep everything copacetic. All right, so we don't know what it is. We know that this is a vector 2. We know that this is a vector 2, but we don't know what we're going to get here. Okay. In fact, there is no return type, so this would fail if I did this. If I said position 1 is equal to position 1 plus position 2, notice position 1 now becomes none. And none, remember, is a class, is a type, right? Because I'm trying to get this to happen, this plus variable to happen, right? And this is where, we're having a bit of an issue, right? So what I need to do is actually return it back out. So that's why when the vector2d happens, sure, I've added them together, right? As an example, yay, self.x is now going to be equal to, whatever it's going to be, right? But nothing's going to happen. I need to return self.x and self.y out. That's what I need to do, right? Luckily for Python, it allows you to do multiple returns in one line. Self.x and then self.y. I can do that in Python. You can't do that in C#. You can only return one thing from C#, right? But in Python, you can do this, right? Which is kind of cool. All right, so let's see now if I did this, if I save this, and if I went back to main, what happens when I go here? Well, now it says it's a tuple or a tuple. Some people call it different things, where I kind of return, and now it's a tuple. Let's see what that position 1 is going to be. Print position 1. So position 1's changed now to something else, and it's not going to be what we thought it's going to be. So if I go to, if I go to, make sure we save that and compile. So Python main. What do we get? Well, we kind of got what we wanted, right? So look, here's position 1, and we added 30, 20 and 10 together to get 30, and then 30 and 10 together to get 40.1. So it kind of worked, right? But now it's a tuple. It's different than what it was before. It's adding those two things together, which is kind of an interesting solution to this addition problem. Okay, so that's kind of something that we're doing. Can you please explain the operating overloading concept as a little? Sure, we can. I can't do plus, right? I can't add two things together that I create right? You guys should know about operator overloading from C#. But if you don't, and if you didn't learn that, that's okay. I can talk about this now in a second. It's like I want to overload the. I'm trying to think of other ways of doing things. I want to overload other things, right? So, there's a bunch of things that we can overload. I can overload comparison operators, equality operators, the multiply operator, the subtract operator, the division operator, the floor operator, the double division operator, the modulus operator, even the power operator. I can overload it because what I want to do is, and I also can do things like the plus equals operator, the assignment operators, plus equals, minus equals, all those kind of things I can do, so that I can add two things together to kind of come up with something else. I want to make my classes work, right? So they just doesn't do one thing. I can't, if I make a new type called vector 2D, I can't add them together ever. I just have, and then they become useless to me, right? So when we overload the operator, it's almost like I make that plus sign work. I make the plus sign work with this. And if I was to take this away, let's just show you how this works. So if I take this away, so there is no overload, right? So, and again, I'm using the triple apostrophe to kind of comment this out, okay? And if I go to my main.py now, it doesn't complain. It's not complaining. It's not like saying, I don't understand, Tom. Not yet. But see, here's a vector 2, here's another vector 2, and then here is an any. I don't know what I'm going to get here. It's not a tuple anymore. It's something else, right? Let's see what we get now when we try it. So clear, it might work, because Python is pretty flexible, but we'll say Python, and then we'll go main.py. And then it says traceback, right? Type error, unsupported operand types for plus. It doesn't know how to add them together. It doesn't know, right? Because it's our own type. We need to tell Python, by the way, in C# and in Java and in C++ and in many other languages, how to add two of our custom types together. This is called operator overloading. How do I add things together? How do I subtract things from one thing from the other? How do I compare one vector to another? How do I do other things, as an example? And so this is the way you do operator overloading for a class in Python. It's pretty straightforward stuff. If you've done operator overloading in C# or in Java, it kind of is explanatory. It's okay, right? It's just a little different in terms of its syntax. That's all. So there's other ones. If I want to also subtract, I need to do the operator overload for subtract. So again, overload the minus, right? So I want to do def __ subtract, right? And I pass in self and the right hand side, whatever the right hand side is going to be that I'm going to subtract. And then I'm going to say the difference in x's, right, is going to be, I'm subtracting the other ones. I'm going to say self.x, right, .x minus right hand side dot. I'm doing the calculation here. I'm doing all the work, right? And then the difference, I can do this all in one line, by the way. Difference in y's is equal to self.y minus right hand side dot y, right? And then what I want to say is that self.y x is equal to the difference in x's, and self.y is equal to the difference in y's. I'm just making it in separate lines, but honestly, you can do this all in one. It's not a big deal. I'm just going to say self. I could just say self.x is equal to self.x minus da-da-da, right? But I'm just doing it this way so you can see what I'm doing. And then return self.x, self.y. So what this does, again, is it does allow me to do the minus now. So this does plus and also minus. I can subtract stuff now, because I overloaded. I defined how to do an add. I defined how to do a subtraction. That's what operator overloading is, right? So if I go to, example back to main. Okay, so I said this, position 1 is equal to position 1 plus position 2. All right, cool. What about if I want to have, position 3, and I want to subtract it? Let's add another position in there. Position 3, let's say, is a new vector2 object. Notice I used the keyword new, but I didn't put the new keyword in there. You don't need to use the new keyword inside of Python. You never use new. You just use the name of the class, right? And then I define a new vector, 100.3 and I don't know, 87.4. All right, so that is position 3, and I can say that position. Let's do another one. I'll say position 4. We'll make it is equal to position 3, and then I'm going to subtract position 2. There we go. All right, and then let's print out position 4. All right, these are just positions vectors, right? So what we should do is get 100. We're going to subtract 10, so we're going to get something like 89.7, and this is going to be 87.4 subtract 10, which is going to be something like 76.6 or something like that. Okay, let's see if that works, and we'll do it again. So we'll say Python main, and then, there we go. So 90.3, 77.4, we did the subtraction. So we can do subtraction now. And you'd have to go in here, I'm not going to do them all, but you have to go here and do other ones, multiplication, division, and so on. Every single operation that you can do, if you wanted to make this vector 2D come alive, then you could do that. So that's something that we could do, and we're kind of doing it for for everything else. Like we're doing it for other things that kind of that we define. Okay, so what I want to do is I want to make it so that I want to make other things like static methods, right? So remember what we did here. Here I use the self keyword, right? Self keyword. So I have to use a vector 2 that exists, and I want to make a calculation. But if I wanted to do something that was static method, remember, doesn't depend on me instantiating anything. Let's say, for example, I wanted some kind of utility function in Python. So utility function for distance calculations, right? So I take in two vectors, vector 1 and vector 2, and I want to find the distance between them. So then I can say distance, right? But instead of me taking self, I don't use self. I don't use self at all, right? I just use vector 1 and vector 2 as the points, vector 2. And I'm going to make some assumptions here that I'm going to get vectors. We haven't done those kinds of checks yet, okay? Because there is no type safety here. If I pass in an integer instead of a vector, and I'm expecting something that has an x and a y, and if I don't get it, then it's going to error out. That's how it is. That's how it works. So my distance calculation is going to work like this. I'm going to have the difference in x's and a difference in y's of both vector 1 and vector 2. So again, difference in x's, that's going to be equal to vector 2 dot x minus vector 1 dot x. And I'm also going to have the difference in y's, right? And that's going to be equal to vector 2 dot y minus vector 1 dot y. Notice what I'm doing here. I'm actually, the only way that I can do this distance calculation in the first place, if I can take two vectors and subtract them. So I had to have done some kind of subtract overload before I can actually do this. Does that make sense? Right? because I'm actually taking two things, and I really don't have to, but I can actually just do a subtraction and get the differences. But here I'm actually taking the components and subtracting them. So the answer is I don't really have to do that. So next, what I want to do is I want to get the square root of the difference of the powers. So what I want to say, okay, so I want to return, if I can spell return, I want to get the square root of the power. So first of all, the powers, what they look like is difference in x's times the difference in x's, power of 2, right? So difference in x's times the difference in x's, right, plus the difference in y's times the difference in y's, right? This is the formula that I'm using, all right? And I'm going to take all of this, right? I'm going to put this in brackets because I need to kind of do a little bit of arithmetic, right? And I want to put it to the 1/2. Okay, so that is the square root of the difference in x's times the difference in x's plus the difference in y's times the difference in y's, which gives me the distance formula between 2 points. And you're going to go, are you sure? I don't know. Let's see what happens, right? Let's see if this even works. So I'm going to go back to here. I'm going to say git add dot git commit minus m. I'm going to say added distance utility function to vector 2D. Git push origin master. Okay, so now you have this thing as well. Okay. Yay. All right, cool. Let's see if it works. So I want to go down here, and I want to have the distance between vector 3 and vector 2. So I'll say something like distance is equal to, now this is interesting, because I have vector 2D, I can say vector 2D dot distance. It's going to be used as a static, right? Vector 2D dot distance. And I'm going to take in, it takes in two vectors, vector 1 and vector 2. Okay, so the first vector is going to be position 4, let's say. And the second vector is going to be position 2. Okay, so position 1, position 2, or position 4 and 2, and then I should get a distance. Let's print that out. Print distance. And again, it's going to be hard to know if it's correct, but let's see if it actually does anything. Because I'm actually using distance as a utility function to get me these two vectors. Okay? If that makes any sense. By the way, the return that I'm getting back is not a vector. The return I'm getting back is a number, right? And it says any, so I'm kind of worried when I see this. When I see any, I'm like, something I did wrong. Let's see if that makes any sense. So if I go back to this, then I get a traceback. And I was expecting it, because you know how I can tell that I'm getting a traceback because of this. Because I'm getting back, when I hover over my distance formula, I'm getting a thing that says, something's not right. So let's take a look and see what it tells us. It says file home Thomas desktop comp blah 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 part 1 vector2.py line 29 in distance diff x's vector 2x minus vector 1x. It says attribute error tuple object has no attribute x, because it doesn't know what these things are. It has no idea what my difference in x's is, right? It doesn't know what this is, right? If that makes sense. Because it's trying to think about it as a tuple, right? Remember we had that other thing? But really, it's not a tuple. It's something else, right? I want to take two numbers. If they're just numbers, x and y, and add them together, no problem. I can make it a static method, right? And so we can use something of a decorator, right? That's something else I can do. I can try using a decorator. I'm not sure it's going to fix me for now. We're going to come back to this later on when we handle. This is just an overview, guys. I don't expect you guys to remember everything by heart or anything like that. But you can use something like an @ sign followed by, if I'm not wrong, static method. And what this does is it tells the compiler that this is a method that's static, @static method. Now, it's not going to fix this problem, right? Because it says, hey, vector2 I don't know what that is, and I'm taking vector 1, I don't know what that is, you know, as an example, and I'm subtracting those two things, right? By the way, one thing I haven't really defined is when my distance formula, it says I'm returning any, right? I'm returning any, and there's ways of defining return types that we're going to do later on, okay? We're still going to get an error, I can tell you right now, because if I go back to my main.py, this is all, by the way, this is all syntax. Once you figure out the syntax, you're good. Now it still says any, that's a problem. Once I see any here, I know that I'm not doing this correct. And I can tell you because I just, you know. Yeah, so it's the same thing. So it says traceback, difference in x, attributes error, tuple object has no attribute x because it doesn't know the type that I'm getting in. It has no idea what type I'm getting, so it can't do the operator, the overload. We're going to come back to this. I'm just going to comment it out. So this part, this is what I want to do. I want to fix the static method, and I'll come back to it and do it because I need to cover other things today. So again, but this is the idea. The idea is that can it be done? Absolutely. Do I remember how to do it? Absolutely not. And why? It's just syntax. I can look it up, but it doesn't matter. You can look it up too. Look up how to do static methods in Python, and you'll see it's pretty straightforward. Okay, so again, adding and subtracting in Python is good. What about if I want to? We've talked about you know, kind of doing things with classes, as an example. But what about you know, kind of doing things with other kinds of things. I want to think about things like, because I want to prepare you guys for data science as an example, which is what this does. It's not quite machine learning that we're doing this semester, but it's going to be Python. And if we're going to use Python, we might as well do a little bit of learning of statistics, right? Because that's really what machine learning is. It's like statistics on steroids, right? So we won't do machine learning, but we'll do a little bit of learning about this. Let's just comment this part out because we can't do this part anymore because I've taken the distance formula out, right, from this. But we'll come back to this. We'll come back and do it again. So what I want to do is I want to use something called you know, descriptive statistics, right? So things like I want to get the minimum, the maximum, I want to get a range, I want to count, I want to get the sum, I want to do the mean, you know, as an example. I want to do the median, I want to do the mode, I want to get all that information, you know, how do I do that when it comes to calculating everything? And there is some help for us. You know, remember we did that whole range thing where I can get a range between you know, 0 and 1 as an example. I can get a range between but 0 and 1 but not including 1, and all that kind of stuff. We can start doing these things. I can start calculating you know, kind of these things together, and we can use something called the statistics built-in. This is awesome. Built-in class that we can use, right? That we can do a few statistics with that it has. Some of them are these descriptive statistics, for example, which is going to be mean, median, and mode. If I want to do mean, median, and mode, which are kind of very, I would say, very useful statistics when it comes to certain things, we can certainly do that in one. So let's try this now. So at the top, I've included student and vector, and I also want to include statistics. This is the one that we're including. Import, we'll say statistics. Statistics is a built-in library. We just have to, when we import it, we attach it to Python. So here in Python, once we've added statistics, I can start doing that. I can say, for example, let's just do it in another file, so that way, you know, I won't confuse you guys more than I've confused you already. Make another file. So we'll go here, we'll add a new one, we'll call this stats .py. There's stats.py, and we'll import statistics. Okay, there's statistics. And now we'll have a couple new values. We'll say a thing called grades. Remember, there's no let, const, or var. And we're just going to have some grades in here. For example, I can have things like some grades. Let's say some people got 65. Another person got 75.8. Third person got 82.1. And I'm going to put some random values in here, that I think are, kind of some grades, whatever those are, right? Someone failed, and someone got 100%. Someone got 99, and someone got 87. 87. Okay, there we go. So we got some grades, a listing of grades here. And once I've got this list of grades, if I do a print grades, remember what this is? This is a list. So again, Python, and we'll talk stats.py. You can see now what I get is a list exactly the way I've input it is the way I get it out, including the square brackets. That's what I get out. Okay, grades. Cool. All right, excellent. But now I can use statistics for this, and I can say that the mean, right, which is the average, is equal to statistics dot mean, and I can pass in a iterable. Iterable means some kind of list, an enumerable basically, something that's a list, and it is waiting for something that's going to be a number. It's got to be a list, an iterable of numbers is what it's looking for. Capital N numbers, okay? So I can say statistics mean, and I'm passing in, kind of grades, right? So let's print that out instead, mean. And when I do that, if I go to clear, and again, classic example stuff, I can get my average is 76.325. That's what it figured out. Right, nice and easy for us, right? To kind of do that. That's mean does all that for us. And statistics is a great library if I hover over it, because it's a module that does some really good stuff for us, and it calculates things with fairly good accuracy. So mean, median. You can hover over here in Visual Studio Code, and it does give you some stuff. Standard deviation, all the basic things of that are built in. That you kind of a lot of things that you look at from a stats perspective. Descriptive statistics are here. Okay. All right, let's try other ones. Let's try, what about if I want to get the median? Well, in order for me to get the median, I need to sort. So I want to say something like, let's sort the list. So I can say grades equals to, and you can use the built-in sorted method. Again, it takes an iterable. I'm going to pass in grades. So basically what I'm going to say is I'm going to sort the grades. And just to show you what this is, so I'll say print sorted grades, and we'll interpolate grades in there with the F, right? And let's try that. You can see that sorted grades now are in order, 25, 65, 66, 75, 77, and so on, right? See that? Whereas before it wasn't. So I've actually changed grades, whatever the original was, to a sorted list of grades. A lot of times we want to sort stuff from least to greatest automatically, because it helps us do things like find the median, right? So if I said median is equal to statistics, and I want to go median and of grades, here it is, that's what median is now. And let's print that out. We'll say mean, we'll say that the mean is mean. Okay. Did I do this too many? I did too many. Okay. And we'll do the same thing. We'll say print f, and we'll say the median is median. Okay. And you know what? Let's do the mode too. Mean, median, and mode. Those are descriptive part of the descriptive statistics array. Statistics dot mode. Right, mode is the most common value. We should get back 77. That's the most. That is the repeating value. 77. Nothing else repeats. It's the most common one. All right. So grades, and then we'll do the same thing. I'm just going to copy paste this one this time, so we can do that. So mean, median, and mode. And then we'll do this. So mean is 76.325, median is 78.5, mode is 77, as we thought. Okay. Questions around this. This is actually a key learning because we did a couple things here. We imported a built-in library, statistics, right? And there's a lot of them that we're gonna learn over the semester, right? A bunch of little libraries that are built into Python. That's why Python is the beloved language of data scientists and statisticians alike, because and machine learning experts, because it's got a lot of really cool functionality built in out of the box, and you have nothing to write. You just have to use the stuff that's here, which makes your job really easy when it comes to figuring stuff out. And it does a lot of really other cool things that that other languages take a little bit more to do. You can do it with other languages too, but you got to figure that this is for somebody who is who starts off as a programmer and who's never learned how to program in C# or in Java. Python is a great little start to learn, right? I mean, really, you learn about algorithms. You learn a bunch of different things, and you don't have to worry so much about too much syntax. I mean, really, there's not a lot of syntax here, compared to other languages like curly braces, right? Curly braces are terrible, right? So, so this is really around statistics. These things here are central tendency. So central tendency is more like, kind of what, the average of, this kind of stuff. And I think this is a really good place to start when it comes to data science. Can I do some basic statistics, that kind of stuff with Python? And the statistics module has a ton of functions. Let's look at that module really briefly before we move on. So if I look at Python's statistics module, so here's python.org. These are all the different things it does. Quantiles, that's awesome, right? So that's great that you can do that. Means, harmonic means, modes. It does population variance, standard deviation, sample variance, which is kind of cool, and a bunch of other stuff. And it gives you some examples of how all this works, which is fantastic. Okay. There's other things you can see, fractions as an example. So there's other modules, fractions and decimal, right? So notice how it does that. From fractions, import fraction, right, as f. You can actually use an alias like we've learned before. F can mean something. So if I wanted to do the same kind of thing, just looking at this, if I can do from this, import this as that, right, I can do that for any one of my my functions, right? So let's try that with our built-ins, right? So I can say something like import statistics, right? And notice that I can say something like, what if I said as s, right? Well, now statistics becomes out of scope, but I can just go s dot, which is kind of a really neat thing. And this is where, like, Python becomes super powerful, like super things that you can do with Python that, I mean, you can do with other languages too, but it's just for the average, scientist or whatever, it becomes something that's very, kind of compressed, compact, easy to run, don't need to compile it, it's ready to go, and this is the reason why we do the things we do with Python. So really cool stuff. Let's get back to that that thing, because I think it's important to take a look at some of that those functions. So there's how it works. There's mean. It talks about the data and what fmean does. And I'm just looking at one module here, and you can see that there's a lot of stuff. It covers many different functions here, and there's other functions just like this one. We just saw two of them, fraction and decimal. And notice that fraction, if I do fraction 3 and 7, and then 1 and 21, and 5 and 3, and whatever. What does fraction do? Let's see what it does, right? So I'm going to do that. I'm going to say import, and we're going to use the same syntax that these guys use, because hey, I'm just looking at this and I get excited when I see this really cool stuff that I can show you. Input fractions from fractions, import fraction as f. Okay. From fractions, import fraction as f. So that is a fraction, okay? Whatever that is. Let's see if we can do that. If I'm going to make a fraction of my own, what does that do for us? Why do we even care about it? So if I say something like, 1/2, so half is equal to f, and then we go 1, 2, right? And I want to print out half, right? Let's see what happens when I do that. Python stats.py. Before we do that, probably want to save, right? 1/2. Look, it actually shows the fraction 1/2, right? So that's pretty cool that it actually keeps it in that form, which is awesome, right? That's awesome, guys, right? So lots of really cool things around this. Okay. So so we've learned a couple things today. We've learned about importing our own modules. We've also learned about importing other modules, right? And I think what I want to leave you with, because I think this is going to help you with your assignment that I'm going to give you next week, as an example, is some files. So I want to open up a text file. I want to save text files, and you're learning about text files right now with me in C#. How does it work? If you're taking C# with me. If you're not, oh well. Let's think about this as numbers. We'll say number. We'll call it numbers.text. And numbers.text will have a bunch of numbers. So things like 25, 34, 48, random numbers. 22, 57, 99, 11, 26, 15, 8, and 3. I don't know. I'm making this up. Okay? And these are the numbers, and I want to read them in. Okay? So let's make another file for you. We'll call it fileio.py. And in fileio.py, I want to think about, there's a couple of steps I need to take when I do fileio. So step 1 is open a file. Okay? So just like in C# where we open up a file stream, we want to open a file object. So we're going to say something like file object, okay, is equal to open, that's a built-in function, and then open what? Well, it says the file name, that's path is like the mode, and notice there's different kinds of modes, right? Read, as an example, write, and append, and a bunch of other ones. Okay, so a bunch of different modes that they give these file streams. So that's kind of like what I want to do. I want to open up a file, right? And I want to be able to read from the file first, right? So I don't want to add data to the file. The first thing I want to do is just read a file, right? So first I open it, and I have to open it in the file name, which is, again, numbers.txt. That's the file name. And then the next part is the mode of reading or writing. So I want to say read. So this is step 1. Step 2, right, after I open the file, I open the file stream, I want to be able to read from it, right? So I want to be able to, you know, to do a read from the file object. So I can say that, so read from the file, okay? This is number 2. So I'm going to say something like contents is equal to, and I want to do file object, whatever that file, you can call it whatever, file, f, whatever, dot read, right? And what this does is it reads in a line, one line at a time, right? And then I want to, the third step, step 3, is I want to, you know, close out the file, right? Because I want to be able to do this. I want to be able to clean up, right? So it would be like file object dot close. Okay, so those are the 3 steps. And then, of course, maybe some other things, some other work. Like, for example, I want to print my contents. And let's see how that works. So this is reading a file, right? And then I'm not sure if we're going to have time to do the other parts, but we'll hit it next week again. So I want to clear. I want to do Python. And I want to use file io.py. And it says, hey, look, 25, 34, 48, 22. Right, so it goes through and read the file. It's that simple, right? If I want to write stuff to the file, if I want to create a new file, right, as an example, and I want to make a new file, I want to override, right, as an example, you know, the file that I want to access, right, then what I want to do is the same thing. I want to do an open, right, but instead of a R, I'm going to do a W, okay? So what this is going to do is I want to be able to, you know, create a bunch of numbers, and I can replace the numbers that are there with something else. If I just did this, if I said something like, okay, I already have my file object. I want to say file object is equal to open. I want to open up the file again, numbers.txt, and this time I want to do a write plus operation, right? And write plus is like, if it doesn't exist, create it. Then what I want to do, this is step 1. Step 2 is I want to be able to write to the file. So like, this is my file stream. I want to do a write stream writer equivalent, like from C#, right? That's what I want to do, stream writer, which is just my file object.write. Okay, file object.write. So let's do that. So first, let's have a bunch of numbers. So we'll say numbers is equal to, and we'll add some new numbers. So 33, 55. We'll just do like a bunch of numbers like this, so we know it's our numbers. Okay, and I don't know. Whatever. I don't know why I did the last one, but I did it. Okay, so there it is. So what I can do then is I can do file object dot write, and then pass in what I want to write. Now, if I pass in numbers like this, okay, it's going to take this and this whole sequence of numbers and write it out, and then let's close it off. So file object dot close. Okay, and then we're going to inspect our numbers. Actually, let's just keep it separate. Let's call this numbers 2 to make it different. Okay, so Python file IO, boom, and then numbers 2 has been created, and you can see now numbers 2 is empty. It says that right argument must be a string, not a list. So right now what we've done is we've made it a string, a list, but I need to make it into a string. So, and this is where we get into this idea of I want to make a range for every element in the list. I want to write that element, right? I want to write that element. So I'm serializing my data on the way out, and then I can deserialize it on the way back in. That's how it works. So let's go back. That's why I didn't wipe this out. Let's go here. So this is nice, a nice idea to write the entire thing, but yeah, that's not going to exactly work. What I really should do instead is do a for loop. So for, we'll say number in numbers, right? And then what I want to do in this range is I want to do that file object.write number. Okay, now if I did this, number, this is still an int. So I need to convert it to a string like we did earlier today. This converts all of the integers to strings, and now the curious thing is, will it write these numbers with any kind of format? What does write do? Or will it write these numbers all bunched up together? How does it write? So let's try it out and see what happens. All right, so it did the read as before, but what did it write in my numbers too? Yeah, exactly what I thought. It wrote them all together, bunched up together like a big string. If we want separation, if we want to encode this so that it looks like something, then we need to add additional information inside of my file. We want to encode and decode. So I'm going to go back to, again, file.io. And in here, when we write, we can write additional things. So I want to do things like, okay, my string, and then what I want to do is I want to add a space, right, as an example, because it's all strings, right? Maybe what I can do is I can add in a comma. So I don't want to create anything. So every time I write something, and then I have a comma, unless my numbers, my last one is also going to end in a comma, right? That's what would happen, because I'm going to do this, keep writing it, and so I'd have to check to see if numbers, the list is if numbers.length, depending on what numbers.length is. So let's take a look and see what numbers.length is. So if I say something like numbers.length, so print, is there something like a dot length or a dot size or a dot count? Everything has, any kind of list or collection has something. There's a dot count, so numbers.count. I want to print that out, and it's going to print that out every time, right, to us, to the console. Let's just do it once. So we'll say, what is numbers.count? Kind of thing. Numbers.count. I want to do this, but this is wrong. Okay. It's wrong because it's going to even do it for the last one, and I don't want the last one to be done for, right? So again, Python, it says built-in method count of list object. That's a method, which means we have to do one of these. Let's try it again. Traceback. It says, okay, count takes exactly one argument, 0 given. All right, cool. I like it. It says it needs a parameter, right, for count, right? So what am I counting, in other words? So can I do count by itself? A counter I can do, right? But numbers, I want to find the count, or the extent of how big this is. And if I go to count and open bracket, and then it says argument missing for parameter, I need an integer, right? Well, that kind of takes away the need for a count. Let's look it up. I can't remember. I'm sorry. And then this is normal, by the way, when you're handling multiple languages. So list count Python, right? And yeah, see the count. I was right. But how do you do it? List is count find the count of elements, duplicates in a given list. Okay. The count of element 3. No, I want to find the size. So that's not really what I want. So I'm using the wrong function. There we go. So list size, Python. Yeah, length. Okay. Yay. And, right. So numbers dot length. How are we doing with time? We're at the end. Okay. And if I did this, it says list object has no attribute length. Is it a method or a, what the heck is that? Is there a thing? I just looked it up. It just showed it to me. Or maybe I just jumped to length of the list. But of course, I didn't look. I just assumed. Length of the list, syntax. All right. So length is a thing. It's not part of a list. Length of the list, numbers. Wow. Okay, so let's try that. There we go. 8. So 8 elements. 1, 2, 3, 4, 5, 6, 7, 8. And I want to find the end of line for the list. Sorry, I keep on doing Command Tab or thing. So list end of file. End of list and Python. Not. So I'm thinking C++. Someone asked me last day, how do you keep it all straight? The answer is you don't. you kind of like, use it, and then you get an idea of how it works. All right, so this is cool. Some list, as an example, and this is the last element of the list. I want to check to see if it's the last element of the list, something like this. That would be nice. And an example will generate an index error. Minus 1 is the last element, so it counts from the right. Pop, I want to pop it off the list. No, but it's like I want to get the list length, as an example, that last element, and I can do that by counting, I guess, which is kind of weird that I already have a counter, but I'm counting. Let's just do it. We'll say count is equal to 0, and as we go through, count. When we count one thing, we'll say count is equal plus equals to 1. We can do that. So we keep on counting, and we'll say if count is equal to length of numbers, as an example, we'll put this here. And then we'll let you guys go. All right? Else. So if count is a length of numbers, then we want to output this part only. Otherwise, do this. Okay, that's going to be inside of my for loop. Okay, and we don't need this anymore. That's just our check. Okay, cool. So we've got this little algorithm that goes for every number in numbers. It counts 1. Okay, cool. So 0, 1, 2, 3, whatever. And then if, now this might be wrong. We might count less than I want. Let's see what happens. Maybe we'll have to put the count after everything else. We'll see how it goes. And ta-da, ba-ba. Okay, we'll see it. Let's take a look at number 2. Pretty good. 33, 55, 66, 77, 88, 99, 110, 121. And notice that there's commas in between, but no comma at the end. Yay! That's pretty cool. And that's the start of us. We just were able to write, and we're going to be able to read. We read the whole thing in, and then we're going to use some kind of string manipulation to cut or split the item in different pieces. And once we can split the item in different numbers, then we can do our statistics and do averages and all that kind of stuff. All right, so that, let me put this up on GitHub. So git add dot git commit -m. And we'll say added file IO example, and then git push origin master. Guys, you're going to need to do this kind of stuff with your assignment. So your assignment's actually going to ask you to do things like read from the command line, which we talked about today. It's going to talk to you about do some manipulation, then write something out to the file. That's your assignment number 1. I've kind of covered most of what you need today, and this is why I was going to give you your assignment. But I knew I needed most of the time, and look, I even ran overtime, which is what I expected. I expected me to run overtime and do this stuff. So I've given you all this stuff. These are some little examples. I recommend you practice along with Python as well. And there are some great resources out there, but the best thing to do is try and do some of the things you know how to do in C#. If you know how to do it in C#, what's the analog in Python? How do you do it in Python, right? And if you can do something that you can do in Python in C#, you're golden, right? That means you can start understanding how things are done, and you can start using Python as another language. Think about it as a second language, right? If your first language is C#, your second language, you won't speak it as well as C# in the beginning, but your second language will be Python. And you can probably get it along, right? Any questions from today before we go on? I'm just looking for any kind of questions in the chat. Guys, thank you so much for joining me on Python Intro to Python Part 2. Next week when we get together, I will give you your assignment, and we're going to do it at a different pace. I wanted to cover a broad spectrum of things this week to give you a sense of how to use Python. And next week when we get together, we'll go at a different pace, more in line with what the other classes are doing, just to make sure that you guys are, I'm not going to try and overload you, no pun intended. It's just, I want to make sure you have the best learning you can. And I believe if I was learning Python, I probably would want to learn it something like this if I wasn't a first-time programmer. Okay? Guys, take care. I'm going to stop recording now, and if you have any questions, I'll wait around for any of your questions to come up.